Hello and thank you to part one of Motor Controllers 101. We're starting to realize that there's some areas in functional safety that may or may not be covered, and from our end users, and I'll show you in a brief summary or survey today, but there's actually an increasing demand on this topic, and this is a newer topic for us here at exida, and actually for the industry. There's not a whole lot of information when talking about safety with motor controllers. Today's webinar, like I said, will be focused around the increasing demand for safety with motor controllers. We've actually recently performed a survey involving our end users, and we were very pleased to see the results. Much of that I will share with you today. We'll start off with a little company history because we always have new people on these on these webinars, and then we'll dive into learning what a motor controller is, how we classify it, is there a true demand for safety, and finally, we'll talk about how to make sure that that motor controller has gone through the process to become useful for the end user to complete their safety system. I'm Ted Stewart. I'm the Program Development and Compliance Manager here at exida with a little over now 10 years of experience in automation systems, manufacturing, and lean process improvement. My responsibilities are that I actually wear a lot of different hats. I help manage the OEM certification division. I'm the deputy quality manager, and I'm also director of the CFSP program. Company was founded in 2000 by Mr. Rainer Faller from Germany and Dr. William Goebel from America. The two of them saw a need in the market. They weren't happy with how things were done, and so they decided to partner together and really start paving a way for functional safety. We are now the leading global consultancy and certification firm where we have over 100 global experts. We've done over 1,000 certifications and assessment projects, and we've actually modeled over 500,000 CIFs. And one unique thing about exida that a lot of people don't realize is the employees all get the opportunity to have a partial ownership of the company. And I really feel that's why a lot of us are so dedicated to this company, is because anything good that comes from it, we also get rewarded. And one fun note to make, that in 2015, ARC, they did a third-party, or really they did their own market survey. We got a copy of the report, and we found out that we were actually the blue portion of that pie chart, where we are actually now leading in safety device certifications. exida, we're a global consulting and certification firm, offices all over the world, and consistently each year now we are growing and developing new offices around that world. We're involved with the complete supply chain of functional safety and many different industry sectors, from the original equipment manufacturers who actually require that product certification all the way to those end users that will use that product. And we've come out and developed many software tools, training, consulting. We have procedures in place, all related to functional safety, security, and reliability. And I'm going kind of brief just so that we can get to the meat of today's topic of the motor controller. But before I do, here's one slide on each of our industries. The consulting side, we help in functional safety, process safety, alarm management, whether it's cybersecurity, alarm management, automotive. We are doing a lot more in fire and gas, and really it's even in API standards as well. We're starting to get more involved. As far as our tools are in place, we do have Excellentia, which is our software suite. It's made up of a lot of different sub-products, like a PHA tool, a layers of protection tool, SIL determination. We have a SIL verification tool, SIL alarm, SIL stat, and really all of our products and services that we have here are all based upon low demand and machine applications. And Excellentia is one of the #1 tools recognized in the industry. This is my area that I spend most of my time, and that's in certification, whether it's in 16508, IEC 61511, ISO 26262, which is automotive. If you're a cybersecurity person, I also will help with that. Machine safety, you name it, we do it. And personnel certification is one of my favorites, because I get to talk to people every single day and help them through their careers. Another great thing about this organization is that we are an open book. At first, I didn't know how I felt about that because you kind of give away all your secrets. However, I soon learned that knowledge is power, and it's so critical for us to make sure that everyone has the most up-to-date information in the industry so that they can help improve their systems and they don't have to rely so much on us because there's so much out there and there's so many people to touch that anything that we do now, we will publish. And it's actually worked for us to our advantage because now, you know, when we get audited, like we did last week, anything that we publish is now public material, and we can now use that to help people get them through their certification or whatever process they're in, and because that's not considered, or it's not considered breaking that impartiality. Because now that it's public, it's free knowledge, it's fair game, it's out there, so now we can just reference people, say if they're going through a certification, hey, go to that functional safety book on chapter 15, and that'll help you out. So today, we do want to talk about motor controllers. We want to talk about the market, if there is a true demand for safety, for functional safety, and then also, you know, how do you select or evaluate one of these items for your safety system? A few weeks ago, we did, Mr. Chris O'Brien spoke about motor controllers, and now I'm going to speak more and limit the different types of motor controllers and only speak about the contactor, the starter, and talk about the motor speed interrupt or those safe torque offs. Because I felt and found that these are the most common areas that people are now using in their systems. What we soon realized looking into this industry is that the classification of a motor controller isn't really black or white, but it's more gray. It's really in the interpretation of the individual or that company. And in this webinar, we're going to share with you our understandings and where we feel each device or element fits. And as you see in front of you, the definitions vary. As a basic definition, that could be, hey, it's just a standalone device, and basically it turns the motor on and off. Other definitions, like you see in that second one, are much more in depth, where this one's talking about how it could be a motor controller could be a manual ways or an automatic means for starting and stopping that motor. It can change the rotation of the motor. It goes forwards, it goes backwards. It can change the speed. It can regulate the timing of torque, and it also can protect against overloads and faults. So let's go ahead and dive into what a motor contactor is. And I know a lot of you already know this information, but for those that don't, it's kind of nice to go through so we all get on the same page. So when we get further in depth, we all have the same understanding. But a motor contactor, now this is a type A device. It means that it doesn't have any kind of microprocessors. It's a simple device that doesn't really think for itself, let's say. Now in comparison to a relay, it's designed to handle more current, and it can be either a single pole or a 3-pole device. This contactor has a coil, and now what happens is it has a coil. Basically, when it gets energized, it can pull that assembly. So if you look in that bottom left diagram to the other one right next to it, when it becomes energized, you can see that the inside assembly gets pushed from the load, and it actually makes the contact. So that now it contacts for the control signal to go in and out, which hence the name, a motor contactor. In the SERH book that's out there, we do have generic data for these contactors. You can see between 620 to 820 fits. And, you know, the variance, it depends on the size of the load to that switch. Now, we have done FMEDAs for specific designs as a baseline, and in the situation that we have, like the one that you have in front of you for a 3-pole device, it came out to 375 fits. So in this application, the FMEDA presented a much better result than those generic numbers. But if you're familiar with how generic data is, it's pretty common to see and pretty conservative to see that your generic failure rates are going to be higher than your more specific use application. And I have a question here. Is a motor controller also referred to as a motor control center? are they the same? Actually, from my definition, I feel the motor control center is one step above the motor controller, where you can have multiple motor controllers inside a motor control center. And the question was, is it a motor controller the same as an MCC? MCC is the motor control center. For me, no, I think MCC is one step even more generic, where you can have multiple motor controllers inside. And if you have any other information, let me know, and I may change my definition according to how you feel as well. Now, in this industry, one question here, the screen is not updating. We cannot see any updated slides. Let me know if everyone's having that problem. I'm going to keep moving on unless I have more people saying the same thing, but I'm sorry if you're having trouble. I have a few people that it is working, so please check your internet connectivity. Maybe something happened there on your side. Thank you so much. I'll keep moving here. Now, in this industry, as it progressed, classifications came out to help eliminate one of the most common reasons for failures in contactors, and that was the misapplication of these contactors. Remember, because they're simple devices that don't normally fail unless they're misused. So what happened was NEMA and IEC both developed their own specifications to help minimize or eliminate this obstacle. When selecting contactors, you'll use either one or maybe even both of those common standards, which is NEMA or IEC. Both match a contactor with the job it has to do, but they do so in different ways. NEMA, how they rate devices, it's typically used in American manufacturing, heavy-duty starters and contactors designed with ease of selection with, let's say, simple maintenance in mind. For example, you could use a NEMA 5 contactor to run a 50 horsepower motor operating at 230 volts or a 200 horsepower motor operating at 460 volts. Now, which is pretty broad. Now, if you go to an IEC rated device, this is it's more internationally used. They're designed with a more specific application in mind. Okay, more like a la carte, where you can size the contactors very close to their ultimate capabilities. In many cases, this precision allows you to actually predict how long these motor contactors are going to last. So, for example, let's say an IEC rated contactor, it may run a motor that draws 40 amps at a full load. Now, in that duty, it should last for more than 2 million operations. But if you used it consistently, well, it was always jogging and plugging, you'll have to replace it after just a few thousand operations. So it's kind of nice if you get down to that level of detail, the IEC can actually help you out. So now what are happening? Manufacturers are actually now offering these products that are dual rated in both NEMA and IEC. Now, let's move on and talk about a motor starter, right? A motor starter has more functionality than a contactor, and it can either be a type A or type B device, right? So type B is where microprocessors are involved, and they actually can start thinking for themselves if they start seeing things. Now, these products, for starters, they actually limit the inrush current and mechanically can limit the torque at the startup operation. And because of these control functions, it will actually help prolong the mechanical life of the motor and actually reduce any voltage dips. Currently, with motor starters, what we're finding is this field it's large. There's many different types of products out there that have many different capabilities, and as we speak, there isn't a lot of IEC 61508 data available, but there is generic failure rate information that we've been able to collect in Excellentia. And more importantly, which has been very exciting, is that we've also begun the process with a few tier 1 companies to actually certify these motor starters to build that confidence around these products to be used in safety systems. And these discussions and the research that have begun are due to our end users who have been now demanding this type of information. And you'll see from the survey what they have told us and what we have seen. Now, let's talk about a few different starters. There's many different types out there, but let's just talk briefly about 5 of the most commonly used. Now, a direct online motor starter is the simplest type of motor starter. Smaller sizes of the direct online starters are manually operated. Larger sizes use an electromechanical contactor, basically to switch that motor circuit. And also with direct online, there's now solid state starters that also exist with direct online. And when we talk about induction motors now, most induction motors are started direct online, but when the motor becomes larger, they cause a disturbance of voltage on those supply lines due to the large starting current surges. So to limit the starting current surge, large induction motors are now started at a reduced voltage and then have a full supply voltage reconnected when they start back up to that near rotated speed. This is where the next ones come into play, your star delta starting and also the auto transformer starting have become more commonly used. The star delta starter, now this is a more commonly type of starter. It is used extensively as compared to the other type of starting methods of an induction motor. The star delta is used for a cage motor design to run normally on the delta connected stator winding. The auto transformer starter, it's suitable for both star and delta connected motors. In this method, the starting current is limited by using a 3-phase auto transformer to reduce the initial starter application voltage. Okay, and I feel like for each type of starter, I could probably go into an entire webinar to explain them, but I'm trying to keep everything brief for today's discussion. Now let's talk about the electric overload relay. This electrical overload relay, it offers reliable and precise protection for motors in the event of an overload or a phase failure. This electronic overload relay, it can make up a compact starting solution together with those contactors. And finally, as the description states, a soft starter. A soft starter is a device used with AC electric motors to temporarily reduce the load and torque in the powertrain and electric current surge of those motors during that startup. And this is just a few of the different kinds of motor starters in the industry. I have a question. Is contactors typically used with DC motors only? Typically, yes. And correct me if I'm wrong, but I do believe you can use a contactor for an AC motor as well, but typically it's used for DC motors. Now, this is a question that I think we hear the most often. People say, hey, look, is it a contactor or is it a motor starter? Well, according to EECO, this question is understandable since contactors and starters both control that electric motor, and many people use these two terms interchangeably. This is where it leads to confusion. And this is how we describe it here. The mechanical elements of a starter and contactor are identical. You got coils, contacts, arc chutes, and both devices typically use a lower voltage, control voltage, to the electromagnetically pull those contacts together. So what's the difference? Well, a contactor is really, let's just call it an overgrown relay. It is but one component of a starter and is rated by voltage. Keep that in mind. The contactor applies voltage to the contact coil to close the contacts and to supply and interrupt power to the circuit. Okay? A motor starter is simply a contactor plus an overload relay, and it's rated by motor horsepower or amperage. If there is no overload relay, it is not a starter any longer, okay? It's back to just being a contactor. The starter employs overload relays to protect the motor from these overload surges by basically shutting it down to prevent overheating. Now, the term motor starter, it usually refers to a complete assembly And this includes, but really not limited to maybe the enclosure, contactor, if there's any transformer, any overloads or fuses as well. So hopefully that helped clear some of that up as far as what they are. At least that's how I specify the differences. So now let's move on to the motor speed interrupt, or the safe torque off. Really, this is a function, and the safe torque off basically brings the stopping function of that contactor into the drive, so that when those proximity sensors are triggered, the drive itself will shut the power to the motor down, instantly performing a coast stop. All right, which is, it just winds it down. Also, there's something worth noting, that it cannot be restarted until the operator instructs it to. So once it shuts down, it stops, right? And it puts it into a safe state here until that operator instructs it to do something. And an STO function is most common in a basic drive integrated safety function, that it ensures that no torque generating energy can continue to act upon a motor, and it prevents unintentionally starting. And that's the main purpose of that safe torque off, or a motor speed interrupt function. So here we go. We've talked about those different types of motor controllers, whether it's a contactor or a starter, if it's a speed interrupt, a safe torque off. Now, is there a need? And this is what generated actually this whole webinar, is the information we received. Now, looking at our database, that people that use Excellentia, what we found out by just analyzing the data, once we realized that there was need, is that 20% of SIFs don't drive the valves, but the motors do, right? So if 20% of SIFs aren't currently being evaluated, so this means 20% of SIFs aren't currently being evaluated by 62508. This information came based off of 82,000 SIFs that have been conducted. And if we exclude relays from the electric final element, here's what you get. You still get 16%, right, that are accounted for all final elements. The motor controller center, right, a motor starter, you see the motor speed interrupts. So you can see, look at the large amount of information, or large, like motor starters of that 16% was 50%. So what that means is that because this is 16%, that says that out of all the SIFs that are done, 1 out of 6 rely on the final element. And this is why there's a need. This is with our internal data before we even outsource to the public to see what they were to say. And this is where the idea took off, and this is when we started looking more into motor controllers. From our survey, you can see the results in front of you. Do you use electric final elements? Basic question, pretty open-ended, but we're noticing that 94% of people use electric final elements. Okay, well, let's go a little bit into deeper information. Okay, well, what percent of your SIFs have that final element? Well, if you look on here, out of the 215 people that responded, 211 gave their opinion, which basically stated, yeah, sure, less than 10%. 23% of the responses said less than 10%. But remember, in our survey that we did internally, we said 16% had some type of SIF or electrical final element in their SIFs. Well, this kind of reassures us and actually says that, there's even 15% of the people out there that over half of their SIFs include these electrical final elements. So it's very interesting to see how many people use these items. So we asked them, okay, of the electrical final elements, what do you use? Now, with relays, we feel relays can be used with other of those items. So I kind of want to just scratch out relay and just say, okay, of the motor starter, the motor contactor, your speed interrupts, the motor operator valves, those are already being certified, so that's not new information. But if we just stay to those first three, the contactor, the starter, and the interrupts, notice how many people are using these devices, and the They're just using the data they have to put into their system, whether it's certified or not. They just use whatever they can. And so end users are now starting to come to us and saying, look, we're developing these systems. As you see, 75% are motor contactors. And I mean, we have generic data, but we have nothing really to specify those failure rates for those products that they're using. We did another survey. We asked everybody, hey, well, okay, so great, you're using these electrical final elements, but who are you using? Who are your main suppliers? What manufacturers? Well, the top 5 are the ones you see in front of you. I don't think it's any surprise that we have Siemens, ABB, we have Rockwell, Schneider, Rotork, but what is surprising is that people listed 54 different companies of electrical final elements. 54. So sure, yeah, there's your top tier organizations which we're working with, 1 or 2 of these already to help to better the industry, but there's 54 just in this quick survey of 200 people that have been identified. Now, here's a very important question, because this could eliminate even doing any research or even working on motor controllers. We asked them, okay, well, how have you seen requests to still certify these electrical final elements? And over 60% of people said yes. To me, that was, I thought that was even higher, because if people are asking for this, then why is the information not out there? Why have people not, until now, for us, seen that this is a true need in the industry? Okay, more of a generic question, but we always throw this on the end of a survey because we want to know, well, what's of value to the end user? Because everything here at Exida is for the end users. Yes, we work through manufacturers and we work with end users, but typically, or always, that manufacturers are making a product to help that end user to put into that system to make basically the world a safer place, right? So we say, look, do you care to have certification through an accredited body? Well, almost 90% of people said yes, which is great. So people are seeing the value in what we're doing. The next highest is that, well, how do you want to see that information? What type of failure data do you want to be used? And people are saying, look, the next trusted thing is an FMEDA, right? Which is great to see, because that means the process that people are going through with the different certifying bodies, those that use that FMEDA approach are what is now the most accepted approach, which is great to see as well. And it's reassuring that, hey, look, if the market, the end users, or the trends showed something differently, we'll adapt and we'll change. We just want to make sure we take care of you the best way possible. So how do we, so like when an end user is choosing a device to incorporate into their SIF, there are 3 major barriers that they must hurdle to say that the SIF is in compliance with 61511. All right, and if I'm talking to manufacturers, here's what we need to start looking into. Right? There's those 3 different barriers where we're talking about the system capability rating, the architecture constraints, the PFD average calculations, and each of these requirements is a barrier that must be considered and hurdled by your customer to achieve the SIL rating for the SIF for that motor controller. Now, each of these 3 barriers must be considered for 61511 compliance. Now, if 2 out of 3 are being met, but the SIL capability of let's say, the architecture constraints are not being addressed, that SIF is not complete, and the compliance of those standards and all that hard work that went into those 2 other barriers are now worthless. They cannot be accounted for, right? So you must have all 3 to hit that center point of compliance. So let's look at these barriers briefly, individually, and then we can open it up to some questions to see if anyone has any, if I haven't already addressed them. So the first barrier is that systematic capability. Okay? Systematic capability is established by basically having your quality management system audited per 61508. If the quality management system meets the requirements of 61508, a SIL capability rating is issued. Now, the rating achieved depends on the effectiveness of that management system. Things like, how you source your part, how you source your part suppliers, how you make modifications, how returns and recalls are handled. These are all considered in this capability rating. And the certificate itself is for that systematic capability of the product. And without product certification, this barrier becomes very hard for your customers to meet this requirement. They'll need to go through a proven in use justification. It usually takes them a lot of time and money when you could actually just provide it for them. And being able to provide that third-party certificate to that customer is for you a huge selling point to supply that barrier. Okay, barrier number 2. We're going to talk about the architecture constraints. Architectural constraints are established 2 ways. You can go route 1H or you can go route 2H. Route 1H provides calculating the safe failure fraction for that element. So a type A device like a motor contactor, it's typically one component of that final element of the safety instrumented function. Okay. In the evaluation of your motor controller, your device will be assessed either by 1H or 2H, or even both of them. And when your product is certified, you can now hand your third-party certificate to that customer, and you can let them know how to use the information that's on that certificate to calculate now their architecture constraints using the different tables in 61511. Okay? And you have the clauses there of where they come from 61508. And of those different SIL tables in 61508 and 61511, they're used to determine the architecture constraints depending on the SIL rating for your customer and what, and on what type of SIF they're trying, or SIL for their SIF they're trying to achieve. Excuse me. And without the product certificate, which is the system capability side that has recommendations for the architecture constraints, your customer is not going to have the information they need and know what hardware fault tolerance or redundancy they have to have in their SIF. And at any time, if any of this information you need more in depth, we have many different webinars and white papers to help go into detail on all these topics here. But today is really about the motor controller, so I'm doing everything at a more top level. Then the third barrier is your PFD average calculation. The PFD average calculation is an equation given in the standards that uses 9 different variances to achieve the probability of failure on demand. Now, it's based on dangerous failure rates, system diagnostics, proof test coverage, test intervals, maintenance and other conditions that are controlled by both your product and how your customers use your device or your element. Now, from the product certificate, the end user can now take the failure rates of the device or element, and with the knowledge of the variables that they control, not you, but what they control, such as how often they're going to be testing the SIFT, how they calculate the PFD average for that SIFT, because it's important, and I stress, it's important to note that that PFD average is not a value that a device manufacturer should be providing. And if you are, be careful, because there's way too many assumptions, because remember, there's 9 variables from the equation that have to be assumed if you don't have them on how they run their system. And providing this value with multiple assumed figures actually can be very misleading and dangerous. And I have a comment come here that is correct, that they believe that the safe failure section of the 2016 edition of 61511 has been removed. That is the case. However, there is a statement in there that says, look, if you have to use the old way, please refer to 61508 to use the safe failure fraction. Because keep in mind that, well, that's with 1H and 2H, but yeah, you're correct. Safe failure fraction is becoming a thing of the past, and they're drastically trying to get away from it. But to their defense, that was the best thing they had going, the committee, 10 years ago. But now they're realizing that it is going to be something of the past. So yeah, you're absolutely right with that. And one other thing while I'm on this slide to note is that typically a Type A device like a motor contactor or other final element assemblies will have a PFD average that only meets SIL 1. However, there are things that can be done now with diagnostics and proof testing that can now jump that PFD average to a SIL 2. And that's truly how that end user uses it in their system. And yeah, how they use it in that system. So now going back to our three-barrier diagram, and with all the knowledge that we just spoke about, you can now see how it's important to have some type of certificate, and from the survey, even a third-party certificate for your customers, because there's pieces of information in each barrier that that certificate will provide to your customers that does not exist to date. All right, there have been work in high demand applications, a lot in the machine industry with these type of motors. However, with a low demand application, it's almost non-existent. The failure information is not there, and this is something that manufacturers are now realizing and quickly getting up to speed. As I said, we have 1 or 2 tier 1 customers right now that we're working on. To date, they're not finished, so we can't announce who they are, but we're working on creating this data for the industry because the end users are drastically looking for it. And one quick point on here as well, just to reiterate, is of each of the 3 barriers that are considered in the 61511 compliance, if 2 out of 3 are met, but that 3rd one is not met, all that hard work is useless. And oh yeah, here we go. Let me put this box down here at the bottom, because this is directly taken out of a type of certificate. Here you're going to see that we highlight, we do show the systemic capability, but we don't specifically state how to use the PFD average or give a PFD average, but we will say, look, it must be verified for each application, and it's not the manufacturer's responsibility. It is the end user's responsibility. And like all equipment used in a CIF, a motor controller must be justified based on that safety integrity. And fortunately, the industry is starting to evolve to a point where we're now working with these different companies on motor controllers to certify them to 61508. So now the end users can have an easier job implementing these into their safety systems. And these safety certified devices, I mean, they're a special class of products. So what you're going to start seeing on SAEL, if you don't know this site, I think my next slide has a link to it, but you'll now start being able to go to a section for motor controllers and pick out which type you need, whether it's a starter or a contactor. If you need the safe torque off functions, if it's a motor operated valve, you're gonna start now go into a special area to pick out these for your systems and get all the product information you need with all the different failure rates. We're very excited about that. And like I said, this is just the beginning. This is Motor Controllers 101. We wanted to touch on this to let people know what we're doing with this industry, that yes, we are seeing your requests. All the end users that are on this call, we see you, and we are definitely taking action to help you out as much as possible. Now at this time, if you have any questions, good question. What about VFDs? Yeah, variable frequency drives. I believe Chris spoke about those 2 weeks ago. Those are very much real. I left them out of this presentation because there's probably 8 or 9 or even 10 different categories I could have talked about with a motor controller. I just kept it to those 3. But yes, variable frequency drives, very much so. Actually, Paul, I'll put some information on that as well, and I can actually send that to you if you'd like. But yes, absolutely. That's another area that we are working on as well. I just didn't speak about it today, but thank you for bringing that up. Yeah, no problem at all. Waiting for some questions here. Actually, what I want to do is I see a great question here that I'd actually rather put into words. That actually came in pretty much at the same exact time. And the question here, and I'll answer this one offline, but I'll give it to everybody. It says, would you expect to see independence between a contactor used in a CIF and a BPCS contactor? And then another one was pretty much the exact same thing. I just lost my place here. As an end user, how should you address independence between the sys and the BPCS when using a contactor as a final element? Good question. I'd prefer to answer that one as a group to everybody, and I'll write down that answer as well. Good questions. I will have those addressed. What's the relationship between 61508 and 13849 with regards to safety? We actually would throw in there 62061 as well. And the relationship is basically what your 61508 is your umbrella standard. However, with machine industries, which you're referring to, it broke out to help specify with the different categories because, you know, your performance levels are different. You got your categories 1 through 4, and so the relationship there is that we actually tie in 62061, and I believe I have an entire webinar for Mr. Chris O'Brien who did the relationship between those two types of standards. I'll dig that up for you, Dion, and send that over to you. When shall data start being used in Excellencia? We already have some failure information currently on there for contactors. We are finishing up some data for the control for starters. If you come back and let's say, fingers crossed, 2 or 3 months, there's going to be a lot more information on these types of devices and elements, and we're very excited about that. If there's anyone in specific you'd like us to reach out and contact, we're working with many manufacturers to try and expedite this information. Please let me know, and we'll reach out to them. What about speed regulation for the motor other than VFD? Yeah, there's many different types of regulations of about the. Well, we did talk about speed regulations for motor, like say torque off, and but in this webinar we kept it very basic. But there are many different types of speed regulations for those motors that maybe in a nearest coming future I'll basically speak about all the different types that are out there and let you know what we're doing with each of them. But for today, I just want to keep it real basic with just like a 101 discussion. I see a lot of these are becoming very technical. That there's a lot of devices that aren't certified. There's a lot of difficulties with different types. I will address each of you individually about your specific situations, and I will have those all addressed. How many has been certified? I believe only 1 or 2 contactors and 0 motor starters have been certified, and that's why this need wasn't there. And now that it's becoming a true need, we've done FMEDAs for them. However, we have not done any certifications. And from the surveys, it shows we need to speed this up and start getting some products out there for you end users to use. Amp guard is the process of having. Who could? Heidi, I'll get back with you and let you know. Actually, if you want, send me a quick email and I'll work with you. I'll work with you with Eaton. Thank you. Let's see here. And yes, there are some special considerations for motor controllers. The question here is, are there special considerations for motor controller verification and energized to safe state applications, like starting a scrubber or coolant pump? Yeah, there are, and we are developing a list of those special considerations. If you have anything specifically in mind, feel free to send me an email. But yeah, we are developing our own list so that when we are evaluating these motor controllers, we can take into consideration and give credit where it's deserved as well. Is exida mainly focused on process industry, hence low demand mode, as opposed to high demand or continuous demand? We're focused in both. However, Denise, there's a lot more information out there on high demand and continuous. A lot of industries use obviously V10 data, but you will find more information on high demand. However, low demand is where it's lacking. And so for me specifically, I'm tasked to gather and accumulate as much information as possible on low demand applications in machinery and in any really process industry. Let's see here. Has exida certified any turbine overspeed protection systems? I believe so, Vishal. I will find out and email you specifically. See, a lot of questions. Thank you. And that is correct, Dion. The question is, if you're modeling a motor trip CIF, would you choose the generic motor interrupt function as the final element currently, but in the future you'll be at the option to choose like an MCC, etc. Yeah, so right now I recommend, and I wish I could have the information right now, but just please select your generic information, because there's too many assumptions made for each application that if you try and get more specific without doing the research, it's not very conservative, and I wouldn't want you to get in that situation. So yeah, for right now, just use generic information until we get into gear and get this from our manufacturers. The question was, for the 2 contactors that have been certified, what SIL level did they meet? Ryan, I'll have to get back to you. I don't have the certificates handy. And let me verify that they did go through the approval process to get certified as well. I don't have that information, but I will have that to you probably as early as the beginning of next week. This is to use B10 figures to generic failure rates and PFD average for low demand. Jamie, I would tell you no. It's nice to know the end of use of a product, but if you want to use B10 data for generic failure rates in a low demand application, I would like to steer you away from that. Let me know what type of device you're looking at, and I can find the generic information for you in a low demand application. But really, B10 data is really used only in high applications, and it really just wants to do the wear out rate. So when that product, if it's run continuously, when is it going to fail? When is the 10% going to fail? So I would try and steer you away from that. How can then user calculate their PFD if the manufacturer shouldn't publish individual PFDs? Well, Brian, that PFD average number has so many variables that manufacturer will not know your proof testing, all the different 9 variables, right? So your mission time, how often it's used, that manufacturer does not know that information. So really what should happen is that manufacturer should give you all the different types of failures, fail safe, fail dangerous, you should know those different failure modes, and then from there you can now calculate the PFD by simply plugging in those different variables. I do have a white paper that explains all the different variables that will be needed to calculate the PFD average. But no, a manufacturer should not supply a PFD average number for you because you don't know what the assumptions were made. And that really should be the job of the end users for that specific application. Let's see here. Is it exactly? Dang it. Does 61800 5-2 have a role to play here? Yes, it does, Denise, and that's one of the substandards that we're using when we start doing our analysis, but absolutely it does. Okay. And yes, I will send everyone out a link to that white paper, so if anyone else wanted to see it, I can do it as well. So, okay, everybody, thank you so much for the questions. If I missed you, there were a lot in there. I tried to go through them as fast as I could. If I missed you or if I did not answer you directly in this webinar, please note that I am going to answer you offline. If anyone would like answers to all the questions, send me a quick email and I'll add you to the mailing list. And you can get the answers to every question that was asked today. Thank you so much. I'll be doing this webinar again in maybe like 5 hours for session 2. If you need anything from me, let me know. My email address is in front of you. If you want to know about anything else going on with Exida, we do have upcoming classes. One thing to note, if anyone of you is in that fire and gas arena, I just found out from MicroPack on that FSE 230 class that for every 2 people, they get a third free. So there you go. That's my marketing for the day. And there's some upcoming trainings. I hope if any of them interest you, great. If you want to get a hold of us, let us know. If you have suggestions on future webinars, say, hey, look, Ted didn't cover some areas of motor controls that I want him to, go ahead, email academy@exida.com. And for those of you that are asking for this presentation and this recording, do know that within the few days, probably by Friday, it will be posted. You will get these slides. And I want to thank every one of you for attending today and listening to me. Take care for now. Bye-bye.